All right, good day and welcome back to Everything Mathematics. Today, Wednesday, and we're moving through geometry day by day, covering new concepts, covering new formulas, covering new working. So, today we're going to move on to quadrilateral. We recently finished our series on triangles, but we're going to come back to triangles because I know next week, Monday, we already have scheduled to look at Pythagoras' theorem. So there's still a lot to know about triangles, but we recently finished looking at areas and so on and so forth. What are we going to do today? So first of all, we're going to define what is a quadrilateral. So we have a common and working understanding of that. We're going to understand the basic properties of quadrilaterals in general. And then we are going to explore specific properties of certain quadrilaterals, at least the main ones, so that we could associate them and understand why it is important to know the properties. So let's go. Generally, a quadrilateral is basically defined as a polygon with four sides and four angles, and or a quadrilateral is a four-sided figure with four angles. And I remember once a child told me, but sir, isn't it obvious if there is four sides that will have four angles? And he had me thinking for a while because at the time I've never been posed with that question. And I told the child, at the moment, I told the child, well, yeah, maybe you're kind of making sense. So then why put it in the definition? But then somebody else in the class that same time, thank God that person was there, or I just saw that teaching the wrong thing, which is okay, it all happens. We have, supposing we have something like this. And then the person said, okay, yes, there, and the person enjoyed it, but it was something similar, right? And they have, okay, one, two, three, four sides. These have four sides, but is it a quadrilateral? And then they all said, no. Why not? It doesn't have four angles. And then say, oh, yeah, well, I guess it's very important to mention the four angles. And in fact, the fact also that we have the word polygon or the word figure, that also draws us back to a plane shape. And we need to understand that one of the properties of a plane shape is that, or a plane figure, is that the figure or shape must be enclosed. So having four sides and four angles is a prerequisite for a quadrilateral and not just four sides. Because as you can see here, something could have four sides, but it's not closed. And as a result, because it's not closed, four angles are not formed. Here we only have this angle here, and this angle here. So yeah, that's a very good question that that child posed for me way back when, and we were able to justify it and clarify it right there and then with that class. It was an interesting mix of students, so thank God that happened like that. Good. So let's go. Basic properties of quadrilaterals now. So let's look at some of these things that we should know. So firstly, we should know that the sum of all interior angles in any given quadrilateral, I should have written that there. The sum of all the interior angles in any given quadrilateral is 360 degrees. That's a must. That is compulsory. And one of the ways in which you could easily test it, is, for example, using any quadrilateral, any four-sided figure. In any four-sided figure, we could draw a diagonal. And a diagonal in almost, I don't want to say all because I don't have all in the top of my head. So I will say almost all. Probably all, it's honestly probably all. But that you have to come good. Once you draw a diagonal in probably all, I will say that, yes, I think I will safely say that. In probably all quadrilaterals, you will get two triangles. And we know that a triangle sums up to 180 degrees. So obviously, if we have two triangles, then it will sum up to 360. That's one way to look at it. That's one way to look at it. Another way to look at it, and is maybe applying more the second concept here, quadrilaterals can be both regular and irregular. And with the regular ones, for example, the regular ones, for example, is square, and this is one we could use for reference. It will have four right angles, and that's another way we could look at it. So four right angles will be 90 times 4, and this is also definitely 360 degrees. So you could commit it to memory, or you could know how to figure it out, right? And even in a square, if you want, even in a square, you could also draw that diagonal thingy, and you get two triangles, a 180 triangle and 180, because all triangles sums up to 180. So it's how you want to look at it, how you want to look at it. Good. And remember, this is helpful to know because just like when we did it with the triangles, you could have a scenario with a quadrilateral in which, let's say they give you this angle, they give you this angle, they give you this angle, but this one is unknown. And understanding that all the angles combined add up to 360, you should be able to find the unknown angle. So that's one of the main things you need it for. And it comes in also very handy in other areas like when you're doing cyclic quadrilaterals, when you're doing circle theory, even when you're doing construction. Understanding some of these concepts helps you to figure out a lot. Trust me, a lot. And when I say construction, I mean construction of shapes, but even construction in real life, yes, it's important. And of course, our quadrilaterals, they must have four sides. Four sides is actually part of the name, quad. Quad is actually a prefix that is often used to represent four. Quadrilateral, quadruplets, what else we have? Squad, just kidding, that is not four. A squad could have many persons. FBI, the FBI, the SWAT. I think I can't remember. One of them groups have a squad in it. Let's go. These are the quadrilaterals that we're going to look at, and I'll just identify them by symbols, and I'll just specify certain things in some of them that you need to know and is important to know. So, first of all, we have the square, and one thing we need to know about the square is that all sides are equal. All sides. So if you have to level a square, you will see it like, if you have two dashes here, we'll have two dashes here, two dashes here, two dashes here. All the angles in a square are also 90 degrees. That's something that you need to know. And also you need to know when it comes to a square that this is also one of the few regular quadrilaterals. Why is it regular? Because all the sides and the angles are equal. And that's what makes a regular shape a regular shape. When all sides and angles are equal. Just like when we did it with the triangle, the equilateral triangle is the only regular triangle because all sides and angles are equal, right? Then we have the rhombus. Under rhombus, I think I'll just highlight two things. There are many things I could highlight, but two things that I think is important to know when it comes to a rhombus is that all sides are equal. So yes, in a rhombus, all sides are equal. And in a rhombus, you need to know that the diagonals bisect each other. This is an important fact you need to know. Oh my goodness, look at where that line falls. Allow me to sketch, but don't mind if you draw this with a ruler. These diagonals, they bisect each other at 90 degrees, right? So you need to know that when it comes to a rhombus. The diagonals bisect each other at 90 degrees. And you may ask me right now, you might be asking yourself, why learn the properties? I could tell you one of the major reasons to learn the properties is especially when we're trying to find areas of more complex shapes, or as we call them, compound shapes. So for example, supposing you are asked to find the area of something like this. So you have something like that, and let me say you put a triangle at the top. Very, very simple generic example. And if you understand, let's assume that this shape below here, I'll just break it up here. Let's assume that this is a square. It is not, obviously we could see two sides longer than the other side. Okay, well let's say it's a rectangle, although we don't do rectangles here, but let's call it a rectangle. And sometimes you're given this side here, and you're not given this side over here. But again, that is where the properties, understanding the properties come to play. Because you know would understand that, okay, if this is a rectangle, we learn that opposite sides in a rectangle are parallel and equal. So if here is 5, even though over here is not given, sorry, it's erased, over here is not given, you should know that here would be 5 cm too. And that is why it's important to understand the properties of quadrilaterals and a matter of fact, any shape. Because when we're dealing with more complex shapes, the properties interplay with each other so that you'll be able to find out and do, I would say, spectacular things. Let's go. Rectangle. Rectangle are pretty close to square. In fact, a rectangle is a square, or a square rather is a rectangle with all sides being equal. The two have the same characteristics. The only difference is that in a rectangle, a pair of sides is longer than the other. So this side is parallel and equal to this side, and this side is equal to this side. So we said that opposite sides in a rectangle are parallel and equal. And that's about it when it comes to the rectangle. Of course, all the angles are 90 degrees, and you need to know that. Rhombus, I will just leave you with the rhombus that Again, opposite sides are parallel and equal. I oftentimes call it parallelogram a lie down rectangle. Well, not quite lie down, but like Michael Jackson. You're almost trying to do the moonwalk kind of thing. Not even the moonwalk, the lean over dance. Yeah, I see the rhombus to the rectangle like that. And likewise the rectangle, the square to the rhombus. A trapezium, this is a very interesting one. And for the trapezium, we generally have two ways to represent it. We have it like this, and we also have it like this. So let's look at one, then two. But two things, one thing that should come in common. So let's call this trapezium 1, trapezium 2. When it comes to a trapezium, the only thing you should really focus on is the fact that there is a pair of parallel sides. Yes, it has one pair of parallel sides, meaning that this top and this bottom here would never meet. And that is true to any trapezium. It doesn't have to be equal, but we have to know that it is parallel. That is important. And what could I tell about a kite? And I tried to put a kite here. I don't know, looking more like a rhombus. This one is often also referred to as a diamond. I never liked the idea of calling it a diamond though, but that's what they teach some students in primary school. And in a kite, really what you need to know is that these two top sides are equal and these two bottom sides are equal, right? And like the rhombus, the diagonals of a kite also bisect at 90 degrees, right? So all these here bisect to 90 degrees. And like any given quadrilateral, of course, all the internal angles add up to 360. So that is just laying the foundation for quadrilaterals. In the next video, we ain't going to waste no time. We're going to go straight into calculating the areas and perimeter of various quadrilaterals. So until then, see you again. As always, like, share, subscribe, turn on that notification bell, share this video with your friends, your classmates, whoever like maths, and feel free to comment if there's anything, of course, that you would like to know or interested to know. Until then, see you all again. This is Everything Mathematics. Cheers.